on SRE, Site Reliability Engineering, and Cloud Performance Engineering in DevOps, friends. Uh, just to introduce myself, my name is Roshan. I am with Isha from last 4 years. On my IT credentials, I have all around 17 to 18, 17.5 now. 17.5 years experience in IT. I have been into various skills. I started my career as a Java developer and then have been into sysadmin DevOps role. Currently, I'm working as a principal SRE with one of the reputed giants. I have been performance engineering professional for 8 years in my career, and that pushed me to become an SRE eventually. Yeah, so I'm pursuing my career as a principal SRE, friends. Uh, Teaching is my hobby. I like to share ideas, knowledge from to everybody. So that's where we are. Okay, friends. So how are we gonna go about this? So this agenda for this demo is to introduce you to a course which I'm coming up with Isa. The course name is Site Reliability Engineering, Cloud Performance Engineering and DevOps. So primarily, if your background is performance testing, engineering, if you have been into automation, cloud operations, so this demo is for you. Okay. Anybody, if you are a developer trying to switch your career into SRE, again, you this demo is for you, friends. So we will be talking about the course. Before we talk about the course, I'm going to talk about. I'll take up a question. We'll start with the question, friends. Okay, and then we'll talk about the course, and then we'll Q&A. Okay, that's about the agenda. So we are starting up with the course. Today is the demo. Tomorrow is going to day one, and it's over the weekends. We are planning up this course 7:30 to 9:30 p.m. IST. So 4 hours a week. It will be in the weekend, Saturday and Sunday, 7:30 to 9:30 p.m. And we'll talk more about this. So that's the timing of the course, and we'll go about the course syllabus. How do we plan it?
How
What
many
are you going to?
sessions?
Okay, how many sessions? So we take up around 45 hours of live session. So you can calculate accordingly. Usually, it will be definitely around 30 sessions.
Wow.
Yes, yeah. So 25 to 30 sessions. It's quite. Um, I started my last batch in October, and because of holidays, it got extended. And I'm just completing that batch, the weekends batch, and I'm starting it. It's like 3 to 4 times in a year this batch starts. It's not very frequent. The weekends batch. We have the weekdays batch also, which runs Thursday, Tuesday, Wednesday, and Thursday, 3 days, 8:30 p.m. to 10 p.m. IST. But that's not the schedule to as for today. As of now, we are planning to come up with the weekends batch. Weekdays not yet planned, friends. Okay, so I'll start the demo with a question. Okay. And that question has a significance to this course. Okay, you will understand um, why we are starting with a question and why that question. Friends, trust me, in this 1 hour, you are going to get some knowledge. That's for sure. That's my promise. So yeah, be there. Now, this is the question, friends. Do you think, friends, everybody, that the performance engineers, 1 second, friends. Yeah. So, friends, do you think that the performance engineers, or I would say software engineers, anybody in IT, I should change this slide now to software engineers. Do you think that they're expected to know these technologies or domains or skills, whatever you can call it? Do you think so, friends? We're talking about cloud, we're talking about containers, we're talking about Docker, Kubernetes, we're talking about microservices, and we're talking about DevOps. If you look at the current scenario, do you think this is a must thing to know for anybody working into cloud architect, cloud operations, DevOps engineer, SRE engineers, even performance engineers. Do you agree? How many of you agree with me? Can you type yes in the chat, friends? Let's see how many yeses. Or how many of you have not understood? You can say NA friends, if you're not able to understand this question. So I can see a continuous yes from all of you. Yes. And why we're talking about this? Because when you see the next slide, you will understand why these things are relevant, why these things are important. You'll understand in the next slide. Because friends, if you look at the software development and deployment over the years, this is the journey that we have done so far. If you talk about the development process, the software industry started around 1980s. Everybody knows about SDLC, right? Software development lifecycle, the how we go about developing a software. We started our development process with waterfall. It had a lot of disadvantages, then merits, but it's something we get started with and we learn along the way. We learned from our mistakes and we progressed. We made our process better. We moved to agile, where we did the development in phases. We call it sprints. Uh, and we took the feedback. We took the continuous feedback from our client stakeholders for each phase, and we progressed. And eventually, we got the much better product. But if you look at the trend, we are talking about agile. Definitely, we are not moving away from agile, but we are talking about DevOps. So, what is DevOps? It's all about automation. Friends, if I ask you, it's a simple question. If you are, most of you from IT, I believe, right? When the code is ready, let's say developer is ready with the code, what do we want to do with that code? Friends, let's understand this. What do we want to do with that code?
First, it will be verified if that. Sorry, can you hear me?
Yes, I'm here. Yes.
First, it will be verified if that is under the
You see, we are not talking
code
about
standards.
the process. I get it what your point is, but let's say eventual goal. When the code is ready, what do we want to do with that code? I understand we test it and we release it to production, but yeah.
Should match with the requirements.
No, friends, code is ready. Requirement gathering has happened before the code was developed.
Deployment, right?
Yeah, deployment.
We will deploy
We want to
right?
deploy the code to production. That's what.
We will deploy in production.
Right? That's what we want to do with that code. But we don't want to take a risk. That's why we do functional testing, performance testing, security testing, UAT testing. We do all sorts of testing. And basically that delays the deployment process. So DevOps focuses on how can you make the process swift. That's what DevOps talks about. So there is no problem with the agile process as such. But DevOps focuses on how can you make the process swift. DevOps talks about SDLC process automation. How can you automate the process? We can write a CI/CD pipeline, right? If the code is ready, let's say the code is in GitHub, Bitbucket. Why can't we take the code, write a script, a job, which downloads the code, builds the code. Let's say the code is written in Java, builds the code. Builds the code means compilation, unit test cases, packaging. Let's say I get a jar file, war file. I can deploy that jar file, war file to a QA environment. We can again run an automated script to do the automation testing. We could have this script using Selenium developed. After functional testing, we can trigger a performance job, which let's say I have written the script in Jmeter, and we can compare the results with the previous build. And if everything goes well, then after the security and everything goes well, why can't we deploy the code to production? We have scope of automation. It's not like we cannot automate this. So DevOps focuses on that. And that's why it is important in today's market trend. We don't want to wait longer. If you go, friends, 10 years back, we were waiting a lot of time after the code was developed. This quality validation phase, functional testing, if it is done manually, then performance testing. If eventually performance testing was at the crunch last time, because functional testing was taking so much of time, to and fro discussions. So that's the agenda here, that we need to understand the DevOps part. Now coming to the application architecture as well. Back then we developed our application in monolithic applications. Now we're talking about microservices nowadays, because microservices gives us flexibility. Microservices means splitting the bigger code base into various modules, independent modules. That's what we call it, microservices. Friends, if I tell you, let's say we have website, let's say Make My Trip. Make My Trip, when you go to Make My Trip, when you search, you provide source, destination, you click on search. It makes a lot of API calls to various flight carriers. It calls Indigo, AirAsia, Air India, a lot of flight carriers, and it gives us the details. If I tell you, if Indigo website is down, my Make My Trip would not work. Or if my Make My Trip is down, Indigo would not work. You would not buy this statement because both are independent applications. I'm just calling the APIs from Make My Trip. I'm making an API call, get call, post call, to search for the flight informations or book a ticket. We're making an API call to Indigo APIs or Air India APIs. So both are independent applications. So within one application as well, let's say if I talk about Flipkart or Make My Trip, let's take this example, friends. If I talk about Make My Trip itself, we have so many modules in Make My Trip itself. I'll do one thing. I'll open a page itself. Let's say if I go to Make My Trip, we have so many modules here, right? We have flights, we have hotels, we have homestays. If I tell you, if I'm not able to book a flight tickets, if this feature is not working, I'm not able to also book the hotels. You would say, why they are dependent? That's what microservices does. Microservices enable us to make it independent. If one module is not working, it should not impact other modules. I should be able to book hotels. I should be able to book other things. If one model is not working, it should not impact others. And that's only possible when we have independent applications working independently. And if the two models need to talk to each other, they can call using API. Within one application also, API calls. We will not depend on the code function. We will not call the functions to get something done. We'll expose the API. We'll make two different independent applications within one application and call API, like how if we search, let's say Delhi, Bengaluru, I search, it makes an API call to so many flight carriers and we get the details. All are independent application. Make My Trip doesn't own Air India Express or SpiceJet or Indigo here. No, independent application, but they're getting the information. Same way within one application, we can call the APIs and get things done. We don't need to be dependent from the code perspective. We don't want to deploy all the code together. That's what microservices talks about. If you look at this, we are trying to make it independent. Friends, we're trying to make it independent applications here in microservices. Now the question is, where do we deploy this? So friends, in a parallel track on a physical server. So this is on the application architecture. Now on the deployment and packaging part, we have also progressed over the years. We started with physical server. See, back then, there was no concept of virtualization. When in 1980s, when we started our software deployment, There was no concept of virtualization. If you have an application, EBs, MBs, whatever it is, size of the application is, we will deploy on the big physical server, directly on the physical server. We were wasting a lot of resources. The cost optimization, resource efficient utilization was not at all in picture. Early 2000, a revolution came, friends, of virtualization. Do we all know about virtualization, friends? Yes, no, in the chat, please. When we install a virtualization software on the physical server, we can virtualize the physical server and we can create multiple VMs. Right now, we can virtualize our laptop also. Let's say your laptop has a bigger, let's say your laptop has 16 core processor, 16 GB RAM. We can virtualize our laptop and we can create 4 VMs in that. 4 vCPU, 4 GB RAM each. We can do that. Virtualization has that capability. Now, when we did virtualization, friends, in each VM, what did we do? In one VM, we install app server. In other VM, we install web server. In another VM, we install database server. 3-tier application. If you talk about the cloud perspective, if you know cloud, AWS cloud, you might know about a service called EC2, Elastic Compute Cloud. We are able, that's the VM, that's the instance. And AWS, the cloud has done the virtualization. They have big physical server in the data center, friends. And they have done the virtualization. And that's why we're able to create VMs. The EC2 instance that we create is nothing but the VM. And in that, they have done the virtualization. They have a bigger physical server. They have virtualized this. They have installed virtualization software like VMware, VirtualBox, Hyper-V, hypervisor. These are the softwares they install to create VMs. And then we can, on each of the VMs, we can deploy applications. This was done on early 2000, friends. Now in 2015, again, one more revolution has come. We call it containerization. Friends, do we know about containers, Docker, containers, container engine, Kubernetes? If you don't know, you should know it. Okay, that's how the market is. That's how you should know. Just attend the interview, you will understand what I'm talking about. If you don't know or never heard of it. In 2015, a technology came which took one VM and we installed container engine on that VM and we could create containers. Friends, it's if you look at this, right, the journey, it has been of the journey of cost optimization. On the physical server, we were wasting a lot of resources. We switched to VMs, we optimized a lot of cost. Now in the VMs also, if you notice, the utilization is 30 to 40% overall. Just go and check your production VMs. You would be not amazed that the utilization is 30 to 40% only. So why are we wasting it? Because the 90% of any company cloud bill, now who's the contributor? What contributes to 90% of the cost? The server cost. And why can't we optimize it so that we can reduce the cost significantly? And the containers, friends, have reduced the cost up to 50%. And that is why it has the huge adoption. In containers, friends, we talk about Docker. Docker is the container engine. So we install Docker engine, container engine, Docker in the VM, and then we can create containers. And then we have something called Kubernetes. The containers needs to auto scaled based on load requirements. The containers needs auto healing features, auto deployment features, lot of features which Kubernetes provides. So we need to know this. This is the current situation of the cost optimization. So there is a reason for it. Why we talk about DevOps, why we talk about microservices, why we talk about containers, there's a reason for it. Cost optimization, huge thing. And that's why every company, now, if you look at any architecture, right, you will be seeing we have a Kubernetes cluster. We using cloud EKS, AKS, GKE. We have Kubernetes cluster. Guys, are we on the same page? Yes or no? How many of you are working in containerized environment? Yes, in the chat. Yes or no in the chat, friends? Look at this. Yes. No is, I see two no and maximum yes. So if it is not containerized, so those who are answering no, so if you whether you don't know or it's a VM, still VMs. Please type in the chat.
It's
Still
just that
VMs.
maybe yeah,
Please.
Roshan, maybe we don't know. We don't know, but they, I
Ah,
mean, the infrastructure maybe they're using
correct.
container.
Correct. That's how it is. Right. So either it's a VM or you containerize the VM and create containers. That's how it is. The industry from last 10 years, friends, I am in IT, and wherever I have joined in last 10 years, it's always about containerization, Kubernetes, Docker, everywhere, the deployment part. We're talking about how do we deploy VM installation. Yeah, it is there, something which cannot be containerized, but it is going to be in parallel. We have to use containers for the cost optimization, and it gives flexibility also, a lot of benefits of using that. Yeah. Okay, VM in cloud. Vignesh, VMs in cloud. Avinash is saying VMs. Tiru is saying VMs. Okay. Sooner or later, friends, if your company is moving towards microservices, let's say monolithic to microservices, they would be switching. There would be POCs going on containerization. Yes, you may want to check that within the company because every company is adopting it, and maybe your company is in the process of transition of doing it. Now the last part here. Where do we get the servers? Where do we get the storage? So earlier, if you have want to deploy something, you have to set up your own data center. That was this was the situation. But now it's not the case. Why so many startups we have, friends? Because we have something called cloud. You don't need to set up a data center which has billions of dollars of investment upfront. Now we can leverage cloud, means the data centers which others have set up. The data centers which others have set up, like Amazon, Web Services, Microsoft, Azure, or Google, GCP, when others have set up data centers, and it's their business model. See, AWS, what they have done, it's a business model for them. They have set up data centers, they have infrastructure, and they give you on rent. It's like same thing, friends. Big builder is there, they have hundreds of apartments and putting things on rent. That's how it is, the cloud. Because we cannot purchase the flat, right? So costly. So we put it on rent. The same thing goes for the cloud. They have the data centers, servers. If I need 20, 30 servers, we don't know about the our business is going to grow or is going to be saturate. Why to put so much of investment in the cloud, in the data center? Just get some servers, get some storage, and get going. So that is why, friends, we need to know these things. And that's where we have put that earlier slide. DevOps, microservices, containers, and cloud is the today's domain, today's skill. Look at any resume, any interview questions. You will not be surprised if 70% of the questions are in this. I'll not be surprised because this is the situation. If you are into cloud operations, if you're into performance engineering, yes, they would ask you some Jmeter questions and performance engineering skills, but eventually they would understand your cloud knowledge, your Kubernetes knowledge. They would check your microservices knowledge. Do you understand microservices or not? Can you automate things or not? Can you create some performance job or automation job in Jenkins or not? They would definitely ask you these questions. And that's where this These four things are become relevant. Sounds good, everybody? Any questions on this slide? Anybody has any questions?
Yeah, yes, Roshan, I have.
Go
Do you
ahead.
hear me?
Go
Yeah.
ahead. Go ahead.
So
Yes.
in microservices based architecture, we were talking about, like, they are interacting through an API, right?
Yeah.
So these APIs are hosted on the same server in a different container, or what? I mean, I know I'm using that, but I'm not have that basic idea about it.
See,
How?
microservices are nothing but independent applications.
Mm-hmm.
If I take you the example, I can create a microservice for flights,
Mm-hmm.
which will have flight logic only. See, when I click on search, this is the web page. When I click on search, the calculations, the calls are made in a different way. Then when I go to hotels and do the search, correct?
Mm-hmm.
Totally different calculation, different logic. So I can host this flight in a different server. I can call this as one application, independent application. I'm giving you one example. This may not be the case here because they are not related. But think like this, that microservices are independent applications. For example, let's say login functionality or any mode. Let's say if I go to flipkart.com, let's take better example. This is a much bigger application. We have mobiles here, we have flight bookings here. Now tell me one thing. Do you think the flight bookings, whatever they have this feature, they would be deployed on the same server with the same code with the retail part of Flipkart? Or should be independent? What do you think?
Yeah, maybe
When I
in
say,
different containers.
yeah, forget about containers. Okay, don't complicate things. Let's talk about from a
Okay.
simple code perspective. Okay, let's keep it simple. Let's not go to container. You'll get confused more. Okay, my voice is echoing. Can you, can you mute yourself? Thank you. Uh, See, microservices, when we say, what do we mean? We need to make it independent. Independent in what context? The code context. I don't want both the codes together. If you put code together, it will become monolithic. What is monolithic? Mono means single, lithic means big. If I put all the code in together, can you imagine how big the code base is going to be? And it will always be vulnerable to problems. If one issue with one module can impact other module because all are packaged together. So the best thing is make it independent. For any logic, if you think this flight bookings, this is a UI page, web. Don't think about web. You don't think that, hey, Roshan, I'm seeing the same, both are together at the same page. No, this is a web part. Web server is the web page, right? HTML thing can be together. What do you do after going that? That matters. The application server part, the logic part. It's a complete different logic. The way you search here, the way it will operate, the logic of the search would be totally different than what I do search here in mobile or in fashion. Yes or no? So I will maintain two different code base. Basically, I will deploy on these two different servers. I will have two different microservices. I will deploy them separately.
Mm-hmm.
Able to understand what is
Yep.
microservices? That's what I'm talking
Yep.
about microservices perspective. Obviously, I will have different containers because both are two independent microservices and they are independent of each other. If I will deploy a jar file of flights, I will not be dependent that I need to deploy jar file of the other retail part, right? Both are independent. That's what the microservices mean. Okay, I'll do one thing. I'll share a diagram with you, friends. You will be absolutely clear. I'll just share one diagram with you.
Roshan, one
Uh-huh.
question.
Go ahead, go ahead.
Microservices, you said independent. So my take from this is these are independent logically. But those are getting built in a different package, getting called through different channels, all those things are fine. But when you say you're deploying a different server, it kind of makes that those are physically different as well. So is it
Correct.
necessary?
Yes. Yes. See, understand this one thing. I'm showing you a monolithic on the left side. I'm showing you the application server. Forget about the web server and database server. Focus on the application server. What do you see here? You have got 4 modules. We have functions in each of these modules. M1, M2, M3, M4. Now in monolithic, what happens? The functions are dependent. If I'm writing F1, I'm calling functions from M2, M3, M4. The huge dependency is there. The functions are being called anywhere and everywhere. There's a huge dependency. We have to package, deploy it together. That's called monolithic. Now, when I say microservices, we split it. I'm not going to call the functions because calling the function will have a lot of problems. Issue with one module can impact other modules. Unnecessary because there are dependencies there. If I'm making a change in M2, in one of the functions in M2 F23, we'll have to deploy the entire code base because both are dependent. Now, in case of microservices, it's totally independent. M1 is independent, M2 is independent, M3 is independent, M4 is independent. If think like if I have one jar file here, if I'll get for the entire web server, I get one jar file here. Here I'm gonna get 4 jar file here. If I'm continue to write my code in Java, I'll get 4 jar file here. I will be deploying it separately. I'll be deploying this separately. I'll be deploying this separately. I'll be deploying this separately. I'll be using different containers because all are different microservices. I'll not go inside microservices. People will not feel comfortable. Not many of you know about microservices. So I'll keep it simple. I will the code from the code perspective, they are independent of each other. I'm not calling the function. If I am doing something in M1, I'm not calling F21 of F22. If I need something, I'll call the get call post call of M2. I'll call the APIs, not the function. That is what we call it two microservices. They communicate like this.
Okay,
Sounds
so
good?
essentially my question was, I do understand those are all different jar files, but is it possible to deploy multiple jars in a single container?
You're again bringing in the containers.
Yes,
We,
because
we, we'll have a lot of discussions in that. First of all, you have to understand containers. We don't do that. Okay, let me keep it simple. If you know containers, let me answer you. We need to deploy on different containers. Each microservices will have their own image,
Hmm?
Docker image, if you understand, right? We will have their own image and we'll deploy separately. This will be having their own container. This can have their own container, own container, own container. Now, it can happen that both are on the same VM. That can also happen, but they are independent containers.
Right. Okay, yeah,
Sounds good?
that was my question.
Sounds good?
Yeah.
Sure. Those who have not, friends, those who are not able to follow the container part, don't worry. Okay. You may get overwhelmed what's the discussion going on. Yeah, go ahead.
Roshan,
Sure.
just a quick thing. Yeah. Can you precise what the question is and the response is just in
Again,
one line? Just
oh
to
no, very difficult. One line, very difficult,
is
Kiran.
it okay?
I'll
Okay.
try, right? It will take half an hour for me, for you to
No, no.
understand, and others will also ask. It will create lot of confusion. I need enough
Yeah.
time to make it clear for all of you. So let's not invoke that question.
No worries. No worries. Yeah, I'm just
Okay.
because this is too much technical, so I was trying
Correct,
to
correct, correct.
decide.
So don't worry. We have everything in the course covered in a very nice, easy manner, step by step manner. Because see, for you to understand this, you need to understand what is container first of all. If that container idea is not clear, you will get confused.
Absolutely. Yeah.
Yeah,
Yeah.
Roshan,
Yeah,
from
go
my
ahead.
side, I have one doubt.
Hmm.
Multiple jar files we deploy to single container running or
No,
not?
no, 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 no. Again, I answered that question. Don't put single container. That's where.
Okay, multiple containers.
Don't. Yeah, yeah, yeah. All are
Okay.
separate microservices. We have one image for this, one image for this, one
Yeah,
image separately. Will be deployed different containers. Don't go there. So if you don't understand containers, let's keep it simple.
I
I don't
mean,
want to go in deep
we
today.
deploy, we different jar files to deploy the different containers, right?
Yeah. Keep it like this.
Okay,
Yes.
okay.
Because if I try to make it simple for you, right, the entire 1 hour will go. So we will take that discussion in separately during the session. Okay. We'll have a very nice way of taking these topics. Few people know something more, so we have to address them also. Okay. Those who understand containers can give me a thumbs up. Are we all good? And those who have not, those who do not understand container, don't worry. Are we good so far, everybody?
Hi Roshan, this is Shashi here.
Yes.
I got confused between a container and the pod.
Please leave it, Sasi. This is not the right time to discuss that. It will take half an hour. So I just wanted to give you an overview
Okay. Just a
today.
high level overview if you can
You
give.
will further get confused.
Okay.
Containers or pods are one and the same. Pods we use in the case of Kubernetes. Containers we use in the case of Docker. So basically, the pods contain the containers. Got confused further, right? That's what I'm trying to tell you. Let's not
No,
invoke. You understood?
pods will have the pods will have
Containers.
container
Correct.
and container will have our microservices. Is
Microservices.
that right?
Correct.
Is
Correct.
that right?
Absolute. If
Yeah.
you have got this much, perfectly fine. Yes.
Okay.
Yes. Okay. Any other question? I see hand raise. Girija and Thiru. Is it hand raise or thumbs up?
No,
Hand raise.
sorry, that was by mistake. I gave
Okay.
thumbs up.
Okay. Cool.
Hi, Roshan,
So
good morning. This is Raj.
okay.
So, can you know a little bit about the data center architecture?
Morning.
How it would be?
Roshan?
What do we want? A data center?
Data center architecture, how it
Or
works?
no. This is not an architecture. It is a normal data center. If you have a software and if you want to deploy that software, you need to set up a data center back then. It's not an
Correct, yeah.
architecture. Data center is a
The
physical
data center
thing.
infrastructure.
It's a physical thing. It's a physical thing. It's not an architecture as well. What is
Yeah,
data
I'm asking
center?
about their infrastructure. Yes.
Come again.
No, I would like to know about the data center and how it works and what is its infrastructure or landscape.
Data center. This is what a data center looks like. Facebook data center, Google data center. This is how the servers are located. This is a data center. I'm showing you one of the Google's data center. And inside the data center, you have these servers.
It's a physical space actually.
So basically,
Okay, so
the what you call cloud, right? You use the word cloud. Basically, cloud, we get the server. But where is the server? Server is in the data centers here. Netflix, we see so much of movies content. Where those content are stored? They're stored in the data center, in the storage service. Netflix uses AWS. So this is called a data center. It's a physical thing. Think like the servers, full of server storage, right? Redundant power supply, redundant internet connectivity. That's the data center. Sounds good?
Okay.
Yeah.
Yeah, thank you.
So earlier, if you have a business idea like Amazon.com, when Amazon.com was being developed, Jeff Bezos had to set up a data center. There was no cloud as such. Jeff Bezos to deploy Amazon.com had to set up a data center. Google, Oracle, IBM, those big companies had to set up a data center. Facebook, they have to keep on adding servers on daily basis in their data center because of their incoming features and a lot of people joining it on daily basis. That's the data center. The when we hit a request, the our request goes to the server. The server is in the data center. We need, and when Facebook like customer base, if you have so much of features, they store so much of content, movie, the clips, the videos, the images, so much of content. They're all stored in these data centers. Their own respective. Facebook have their own data center. Google has their own. Amazon Web Services, they have their own. Microsoft have their own. Oracle, IBM, HP, they have their own data centers. Okay, sounds good.
Yep. Thank you.
Okay, any other questions on this slide? If you have understood, friends, high level, yeah, because we need to a deep, we need a thorough understanding, and it'll take some time. And that's why this course, okay, because I understand. So friends, so we'll talk about the course now. So our course is design is based on these four things. In our course, we talk about AWS. Let me show you about the course, friends. Uh, if you look at the course content, today is the day one. Okay, demo has started. We are gonna start. Tomorrow is the day one, and we are starting from day one. Okay, so and the timing would be.
Roshan,
Go ahead.
sorry, Amol here. So are we focusing from the AWS perspective in this all these sessions, or
Correct.
we are going
Correct.
to touch up the GCP and Azure as well?
See, we don't touch up, but see, understand one thing. Okay, to answer your question, we only talk about AWS, and we should
Okay.
focus. If you are learning cloud for the first time, we should stick to one cloud, and
Mm.
then it's easy to learn others. It's like
Yeah.
if you know one performance testing tool, the concept perspective both will be the same. The look and feel would be the different. That's how it is, right? So because the use case is same, everybody
Okay.
we use AWS to get the server, to get the storage. Like the look and feel would change. The use
Yeah.
case would remain the same. So it's always best to learn if you are starting from scratch. Pick one cloud, any cloud. In this course,
Mm-hmm.
we'll talk about AWS. Pick one
Okay.
cloud, learn thoroughly, and then it's easy to learn other cloud if you are interested.
Oh, yeah,
Like
understand.
personally, I have worked on 4 cloud to as of in my career. Uh, hands-on, okay, hands-on 4 cloud, AWS, Azure, GCP, Oracle, 4 cloud
Mm.
hands-on, because I was working with Oracle also. So it's you just focus on one cloud and its
Yeah.
rest will follow. That's how it is. Okay, but we focus on AWS. Okay, now
AWS. Okay. Yeah.
yes,
And one more question linked to that only. So all the containerization and microservices or Kubernetes, Docker,
we're
what
gonna
we are going
cover.
to
We are
learn.
cover. We'll
Yeah,
be
yeah,
you'll
yeah.
be
But what we are
understanding
going to,
this.
yeah, that will be based on a single, based on the AWS platform at the moment. I mean, this
Correct,
session we are going to
correct,
cover that.
correct,
Yeah.
correct.
Okay. Okay.
Just wait for half an hour. You'll understand everything.
Yeah.
Sure. Okay. Now we are starting, friends. Today's demo, and we are starting from tomorrow, our day one, and we'll start directly with cloud. Now, what do we do, friends? We start with AWS from scratch. See the USP of this course, right? Is that we take it from scratch. I understand that my audience. Kay, can you? Is it a question raise? Hand raise? Thank you. I understand that my audience has no idea about cloud. Whatever the topic that we have in this course, I assume that my audience, all the learners, have no idea about this. So completely new. And that's how I take things up. If you don't know cloud, if you don't know DevOps, if you don't know what is microservices, monolithic, if you don't know container Kubernetes, it's fine. It's fine. I can teach a 12 standard anybody also. That's how this course is designed. Okay, from scratch. No prerequisite. Yeah, some basics. If I talk about IP port, you should be able to understand those things. Server, so that's the basic requirement I have. Nothing else. So we talk about cloud, friends. First thing we talk about AWS. Lot of things. I'll not go in detail, okay, because you will feel overwhelmed because you may not know all these things. But we have good coverage here. After this, even after this, upon few guidance, you can also write solution architect associate certification also upon few guidance, not from this few guidance. I'll talk about that. If you're looking for the certification, I can guide you. But that's going to be the base. Whatever we have discussed, that's going to be the base for your cloud knowledge. And this has just enough information what you require to have to work as an SRE engineer or excel your career into performance engineering. To call yourself a cloud performance engineer, cloud operations, DevOps, SRE, this is just enough information. We talk
Yeah.
about cloud.
So, Roshan, one more thing, just now what you said
Yeah.
based on that. So, cloud performance engineering and SRE, what will be, is there much difference?
Can I
Will
take
there
up the
be?
questions at the end, please, Amol? I
Okay,
don't want to break the flow.
okay, no worries.
Let me cover it. Okay. So
Yeah,
hold on. I'll take up all the questions. So just be rest assured. Park your questions. Just make a note. I'll come to you.
sure.
So we talk about cloud, friends. What I've understood that people are not comfortable with Linux is my experience. If I ask you to open a file in Linux server, open a file, edit something, save a file, or open a file or search for a text in a file, I believe that few people would be able to do that here in this forum as well. Because that's has been my experience. It may be wrong also, the percentage wise, but in general, people are not comfortable with Linux because they have never been exposed or they have been working mostly on Windows. Like in Windows, somebody asked, right? Open a file, edit it, save it. We know. Double click, open it, write something, control S, close it. But can we do the same thing in Linux? Because just Linux is operating system. Can we, like how we do control F? We open a file, do a control F, search for a text. We can replace also control G. We do all these things. But can we do in Linux? And it's required, friends. The knowledge of Linux is required because 95 to 98% of the deployment happens in Linux, not in Windows. Okay, enterprise deployments. As an SRE engineer, we need to debug things into production. We need to figure out issues in production. See, that's the biggest difference. Okay, if you are want to understand what is the difference, core difference between a performance engineer and a SRE engineer, troubleshooting skill is common. As a performance engineer, also you need to troubleshoot things. We simulate the load, and in production we get the load. That's the difference. But we try to create production kind of load in both the scenarios. In production, you will have, that you're working on fire, right? It's a live situation. You cannot play around. As an SRE engineer, the role is to, as the name suggests, site reliability engineer. You need to work towards reliability of the production systems. You should be working about high availability. How can you make sure the production systems are highly available, reliable, fault tolerant, highly performing, secure? So these are the attributes of an SRE engineer. In a non-production environment, we don't get that heat, that the pressure, or because we run in a simulated behavior. Sometimes we're able to simulate the load. Most of the time we are not able to simulate the load. And we sometimes say we are okay, no issues, but sometimes we get issues in production. Most of the time we get issues in production. These things are common. So basically we need to understand from a production customer perspective what needs to be done for high availability. So to troubleshoot things, friends, when servers are deployed in Linux, you have to go over the logs. Sometimes you have to go inside the server, look for the logs, be comfortable with Linux. So the Linux is required. So we are covering Linux part as well. Okay. We are talking about the SRE concepts. What is reliability of a system mean? What is fault tolerance? Do we understand this word? What is disaster recovery? What is high availability? What is SLIs, SLO, SLAs, error budgets? Do we understand in the incident management? How do we do that? Change management. Do we understand all these things? So we're talking about these things in this course. We're talking about monolithic applications versus microservices. What is the difference? I just given 5 minutes of trailer in the first slide, but we'll understand in detail here. Then eventually, how do we create containers? We'll talk about Docker. My voice is echoing. Abhinas, can you mute yourself? Thank you. We talk about how do we create containers. Because what do we do with containers? We deploy the microservices. So this is very important, friends. On one part, friends, I am breaking the application. I'm making it highly available from the application side. I'm making code independent. That's parallel development, parallel progress over the years. And parallelly, we are working on the deployment, making the cost optimization. And that is where the microservices getting deployed on containers is the deadliest combination, the most cost optimized solution which exists today. As of today, we don't know about the future, what could come. But as of today, the most cost optimized, stable solution is microservices getting deployed on the containers. And we need to understand this. Is my voice breaking? Swaroop is saying. Friends, is my voice breaking?
No, Roshan, not for me.
Cool. So we need to understand what is microservices and how do we deploy this? You may be deploying applications on the VMs that are going to be outdated anyway, today or tomorrow. The future, this is your company may be in a state that they cannot transition to microservices. They are such a monolithic application they cannot transition because all the newer developments is happening on microservices. Look at any solutions around. Ola, Uber, Swiggy, whatever. All the development is microservices based and they are using Kubernetes, containerization. This is the situation. So if you are not already, you should start your journey, learning journey at least so that you can switch your career. And yeah, Polemy, I'll take up the questions. If you have something very urgent, you can ask.
Not urgent, but I do wanted to know what you are going to teach about the cloud monitoring, because cloud
Okay,
based.
it's coming. Just if you wait for some time, it's coming on the. We are going to cover. Yeah, it's there. I'll come there. Fine. So it's very important. So friends, we talk about the monolithic applications, microservices. How do we deploy microservice containers? How do we deploy monolithic applications? Kubernetes. What is Kubernetes? Container orchestration engine. I don't want to go in detail right now. It will be overwhelming for you. Try to understand high level. If you know these topics, is good. We talk about DevOps, how performance engineering fits into DevOps lifecycle. What does shift left mean? How do we create performance job in Jenkins? How do we create continuous performance testing in Jenkins? Creating Jmeter job so that it can schedule. I was talking about the pipeline, remember? CI/CD pipeline. Performance job, automation job is one of the jobs. When the code is ready, we need to automate this process, CI/CD pipeline, so that in an automated fashion, the codes get deployed to production. And we need to help the organization, a DevOps engineer, with our jobs. If you are a performance tester, we need to create such things. We talk about gaining resilience and reliability on AWS, friends. We talk about a lot of services. RDS, we have databases services, we have Lambda, EC2, load balancing, auto scaling group, EKS. Now, you're asking about monitoring. So we cover these things in monitoring. We cover about Linux monitoring. If you don't have anything from scratch, how can you write a shell script which can monitor things? Then from the cloud perspective, we have CloudWatch. AWS has out of the monitoring service called CloudWatch. We talk about that. Along with that, we have, okay.
There are paid matrices for CloudWatch. So in this course, are you going to cover those matrices which are paid as well?
No, see, we are going to let you know what is CloudWatch, what it does. In general, whenever we talk about anything, Paid and all, I'm not sure. You can enable it.
Because I saw you have created I think the course content had a dashboard. So I thought, I mean, what extent you have the capability to.
I will be creating a dashboard, but I don't know with what context you are looking. I'm going to demonstrate how do we create a dashboard, how do we add metrics to that. Now you're talking about 100 other metrics. You can enable paid metrics, get other metrics. So I will be demonstrating, let's say 10 metrics. You are talking about other 100 metrics. So you can pay and get more metrics if you have that option. But I'll be demonstrating how do we get a dashboard. I'll be showing you that.
Okay.
Roshan, sorry, I mean, it's related to the same. That's the reason I'm asking this now. When you say like you're going to show like how to create the dashboard and all, not for the paid, but in general, are we going to also have that hands-on when you are doing that, or it will be?
See, I will be showing you. I will be showing you, right? Hands-on. It will be my hands-on. Now your question is, would you be getting time during the session to do this?
Yeah,
That
at
will be
least
too
at some
difficult.
extent.
Yeah, that will be too difficult because to wait for everybody. See, we go slow. If you are really interested, you can find a way around. You can. So, Roshan, can you wait for 2 minutes, 3 minutes, 5 minutes? I'll wait, right? But that's how it's going to be. Because if I wait for everybody, let's say entire course would go in that, right? So I would be doing hands-on. I'll be showing you. You will have the recording with you. You can do that later, right? That will be always there with you. But if you want to do, let's say you're doing something along with me, so you need to be up to speed. You cannot ask me to wait for 15 minutes, 20 minutes, half an hour to do this, right? Because we are meeting for only for, let's say, 4 hours in a weekend. And if you make me wait for half an hour, then it's not gonna work, right? So
yeah, okay. And same for the Docker and container as well. You are going to show how you are creating and
everything is hands-on. It's gonna be my hands-on. You will be seeing me do things. No theoretical thing. No theoretical thing. Everything is hands-on, friends. When I say I'll be installing Docker, I will be creating a VM. I will be installing Docker. I will be creating containers. I'll be deploying it. I'll be running Kubernetes cluster. I'll be deploying pods. I'll be deploying services, load balancer, ingress, HPA, everything. I'll be doing it hands-on.
Yeah, and that hands-on what you're going to do that like in actual as the industry standard, SRE will also be doing the same thing, right? SRE people will also be having
You
those
have
sort of.
deviated from your question. Okay, now you're asking a bigger question. Now to answer that, see, it's gonna take a lot of time. See, understand, SRE have lot of responsibilities. Will you be doing the same thing? Nobody can assure of that. But would this knowledge be beneficial? Yes.
Okay.
Would I be doing this in any of the company? Yes. Would I be doing this in all the companies? No, may not be. So it depends, right? But would this knowledge be beneficial? Yes. If I talk about Kubernetes, if I show you how do we deploy deployment.yaml, how do we do services, load balancing, ingress, HPA, cluster autoscale, if I'm showing you ingress, this knowledge will be required. Will you be doing the same thing which I'm showing you hands-on? May not be.
Okay, understand. Yeah, thanks, Roshan.
Sure.
Hey Roshan, thanks for taking up the questions. Like I have one more questions to ask. You will have like do a demo of creating a dashboards and all those things, but we will really get into a challenge when we start creating it on our own outside of the session. So will there be a separate Q&A session or like help?
See, that is very much flexible. Okay, if you are doing hands-on, you will be added to a WhatsApp group where I'll be there. You can ping me in your daytime also. If I'm available, I can message you, reply you there. Or we will meet over the weekends and discuss about that.
Yeah, that will be helpful.
Yeah.
See, I'll show you. I'll show the live. You can see my mobile WhatsApp. Okay. I have a group, December, October batch. We just completed the October batch. So I'll be added as a part of this group. You will be notified of the playlist, all those sessions. You can ask me questions. I'll be there in this group. you will be creating a separate group, something like this, right? So yeah.
Okay.
Roshan, one more question. In the content here, right? I can see one is highlighted with the yellow content, and another one is a plain.
Okay.
Is there any difference?
No difference. It was something added 1 year back, 2 years back with some new content. So we did this. So yeah. Okay, let me complete the remaining part, friends. We'll take up the questions. Okay, I understand a lot of questions.
Roshan, just one question. SRE interview, will we have any development questions or it's like
See,
non-development?
it has been a trend in the industry that first round is going to be programming interview, right? You will be asked to write some programs. That has been the trend. If you go over join a good company, I'm talking about more than 30 lakhs, 35 lakhs package. Okay, they will ask you some programming questions in the first round itself. So yeah. So you need to have automation knowledge, scripting, at least shell scripting, Python scripting, not like a developer knowledge, but at least how to automate these things. You should have that. Okay. You'll understand this once I complete this, right? Most of the question will be cleared. Okay. So give me friends 10 minutes. I don't want to wait. Hold everybody for a lot of time. Just wait for some time. Your remaining question will be cleared off. So friends, we talk about Linux monitoring CloudWatch. We also talk about the open source Prometheus and Grafana and Elastic Stack. People ask me don't we take about Dynatrace AppDynamics? So I replied like, if I take everything, then this session would go for 6 months. Okay, entire course. So we have selected open source monitoring tools, which we go over. And if you have want to learn Dynatrace, there are so many tools, right? I cannot take all the tools. So we are talking about open source tools. How do we set up, install dashboards and all those things? We talk about that. Along with this, friends, we provide 10 hours of Java performance engineering recorded session. Okay, so out of this, there are 2 recorded session. Okay, the Linux part is a recorded session, my recorded session itself. Okay, the Linux part, which I was telling you, this is the recorded session, 3.5 hours. Earlier, I should take that, but it used to be getting a lot of long, lengthy 4 months. So we have just reduced that. So when you enroll, I'll be giving you access here to Linux. So at least you understand ls, cd command basics, 3.5 hours, like this. Okay. Let me show you the playlist, the Linux playlist. You'll be given access to this playlist, which covers just enough information. See, we can dump 10 hours of video, 10 hours of content, but that doesn't make sense. I want to share just enough information so that you can get started, you feel comfortable, you feel confident. So these 3.5 hours of Linux is what we share. It's my recorded session itself. Now we are stopped taking as part of live sessions, but it's like a live session itself. I'll be doing things here. I'll be showing you executing commands, all those things here. And along with this, we are providing the Java performance engineering recorded session. Again, it's my recorded session. We earlier used to take these live sessions, but we have removed it again to make this batch complete in 3 months. If not, it will go for 4 or 5 months, friends. So we cover this 10 hours of Java performance engineering. Let me show you the playlist which I share with everybody. This is the playlist. It's going to be my recorded session. You can ask questions. So we talk about JVM architecture, memory management, GC algorithm, heap dump, thread dump, all those things here. And in general, if you have any questions, any challenges in your day-to-day work life, right? You can, or challenges that you're getting in the company, we can discuss. We can, after the session, we can discuss 5, 10, 15 minutes, and we can so feel comfortable with that. So this is what we'll be sharing the recorded session. Apart from that, whatever we have listed are the live sessions. Live session, when I say, is like this. This is going to be the live sessions. So this is like October, just now we have completed this batch. So every day they will be recorded and we'll be sharing this recording. So as you can see here, 19th October we started and we completed on 23rd Feb, and it took around 34 sessions. So yes, so we have been taking this question. So that's
Yeah.
how it's
So
going to. One
Roshan,
second, not
yeah.
completed. Just can you hold on?
Oh yeah.
No, it will be again.
No, it was about this about the session only. I mean, the recorded session which you have shown. I just wanted to see if you miss any of the session, we still have the recorded session
Yeah,
available
yeah,
in the
yeah, yeah,
gateway,
yeah.
right?
You will have, right. Every day we will be putting it here.
Okay, yeah, that's fine. I thought like you will provide at the end of the course,
No,
so
no,
that's the
no,
reason I
no.
asked
This
you.
is on a day weekend basis. Every
Okay,
weekends it will be uploaded.
okay, okay.
And it's live. What we have recorded, it's that will be uploaded, not older batch.
Correct.
These are live sessions. Okay, so we talk about, as an SRE engineer, we need to talk about automation. We talk about Terraform. We talk about Ansible. We talk about CI/CD pipeline. We talk about automation of mundane scripting, self-scripting, Python scripting. We'll be talking about that, right? So, and along with that, friends, we provide uh, core Java. Again, it's not my recorded. We provide core Java programming knowledge and Python. Okay, Python we only provide to SRE engineers. We have another course called Cloud Performance Engineering and DevOps. Okay, in there we don't provide Python. That's the only thing we don't provide there. Apart from that, everything course content is the same. Okay, only the Python programming knowledge, programming thing we don't provide in the cloud performance engineering and DevOps. Only this is additional in the SRE. So this is about the course.
Roshan, how Python will be beneficial for SRE?
Okay, see, we as an SRE engineer, we need to understand few things about SRE engineer. Okay, so what SRE engineer is responsible for? Okay, so if I sum it up, let's see, if I keep it simple, SRE engineer should have the skill sets of a performance engineer. Like the troubleshooting, I would say the troubleshoot, not the Jmeter knowledge. Yeah, if you have it, it's good. You can help simulate some load tests and all. But the troubleshooting experience is what requires, because as an SRE engineer, you're supposed to make sure production is highly available, reliable. You understand architecture, you understand high availability architecture, and that's what we will talk about in the course. You need to have automation skill sets, and
So,
that is when your your Python scripting, your shell scripting, your Terraform, your Ansible, your CI/CD pipeline will be helpful. All these things, right? And you should also have so here, Terraform plus Ansible plus CI/CD pipeline, which we cover,
y-
plus
you mean
shell
Python will be used for automation kind of thing?
automation. Automation, yes. Python scripting, not the programming knowledge, yes.
Thank you.
See, if your interviewer asks you automate, if you're comfortable with shell scripting, you can do this. Or somebody comfortable in Java, they can do this. But Python is for automation. Python is we have a lot of packages to offer in Python. That's where. Now, along with that, the third skill that we require as an SRE engineer, friends, as a DevOps deployment. When I say DevOps skill, we talk about a deployment. We need to understand how the deployment works. Deployment strategies. How do we deploy things? And security.
Is it
These are the
included in the course? Sorry.
correct. Correct. Everything is included here. Security. So we talk about these four things here. Okay. These are the skill sets of an SRE engineer. Like to sum it up, you may be working, see, somebody could be hired to just work on Terraform. An SRE engineer, you can find SRE engineer which they have hired to work on Terraform mostly. some Terraform or SRE engineer could be hired to work on production troubleshooting. Can be only. Or SRE engineer could be hired for the deployment strategies also, like a DevOps engineer. Right? See, we are talking about summing it up in this course. That's why it is a vast course, because we are trying to get all the skill sets required to call yourself an SRE engineer. And that's why we talk about a lot of things in security, friends. We talk about IAM, we talk about security group in cloud, we talk about NACL, we talk about flow logs, we talk about guard duty, we talk about these things in this our course in security perspective. This is what the SRE engineer makes, and this is what we're covering in the course. That's why it's a vast course. It takes time. As I was showing you.
Yeah, sorry, Roshan, from your point of view, whatever the topics you have just shown, what is the major role of SRE? Is that because, as you said,
Okay, I got your question. I got your question. See, I told you, right? An SRE engineer could be hired mostly to make sure, as the name suggests, reliability, to make sure production is highly available, reliable, secure, highly performing, cost optimized solution. That is the role of an SRE engineer. Now, when you extend that, you will understand that we're talking about all these things.
Yeah, okay. But then cost optimization, you are going to cover that part as well, like how
Correct.
we are going to.
Correct.
Okay.
How do we do cost optimization in the cloud environment?
Yeah. Right. Okay.
That will cover as part of cloud. You'll understand for every topic. For every topic, we'll keep on talking. How can you optimize cost? That's why this course takes longer. Okay. And that's why these topics are well captured. That's why. No, okay, that's not the end, friends. What do you get? Like, you'll be getting the recorded sessions, but also you will be having, friends, access to all the PPTs, all the documents that we have. Okay, so if you look at this, so these are all the PPTs, all the documents that we have and we share. Okay, these are the list. We talk about cloud. We have PPTs for cloud here. So if you open the PPT for cloud, we have PPT for Linux. We have PPT for orchestration engine, container orchestration engine. We have everything. So if you talk about the cloud perspective, we have approximately 150 slides here, and we cover all of them. Okay. Similarly, if we talk about Kubernetes, we'll have similar 100 slides in Kubernetes here. In the Linux part here. On the SRE, if you go to SRE, we have monitoring tools, Java performance engineering, which I was showing you. Along with the PPTs, I share a lot of other materials as well, which will help you to Java performance engineering. Some documents. We talk about a lot of things about automation. So eliminating toil is the automation. We talk about Ansible, Python scripting, Terraform, monitoring tool. I was showing you. We talk about Elk, Elastic Stack, Prometheus, Grafana. Right? We talk about these things. So you're going to get all the recorded sessions playlist along with these documents as part of the course, the live sessions, right? So yeah, that's all I wanted to share. You can ask your questions now.
Yeah, Roshan. So one thing, so when you cover about SRE plus DevOps, right? So in that case, like when you put in a resume, like there might be a question of instead of AWS, there might be a question of Azure and all, right? So how we are going to cover in that case?
See, one thing you need to understand, nobody is going to reject you on the basis that you only know AWS. they know that if a candidate knows one cloud, let's say you can say like this: I have done worked on AWS in and out. I can pick Azure. I have never worked on it. They are not going to reject you on that basis. They will check your other skills. Cloud is one part. And they know that if the guy has worked on in one cloud, this guy can easily pick in any cloud, given just UI. See, understand one thing. When you ask this question, right, it means that you need to understand the use case. Why do you use the cloud? I want to get the server, correct? I want to get the storage.
Yeah.
I want to get the load balancer. I want to get auto scaling group. I need to get the security. Every cloud has the same thing to offer. The look and feel will change. The name will change. Here I'm calling it EC2 instance in AWS. In Azure, I call it virtual machine. In GCP, I call it compute. The look and feel will change. The use case would remain the same. You need the server, storage. Netflix uses S3. Similar service exists in Azure also, in GCP also. I will tell you about that. What does they exist? The look and feel. I may not be able to demonstrate in all the cloud, but I'll tell you what is the relevant service. That is how you need to understand that every cloud offers the same thing. The UI would different. If you look at the cloud, this is how the look and feel is of AWS cloud. This is how AWS looks like, console. If I talk about GCP Azure, it looks different. If I want to get the server, I go to EC2 and get the server here. You want to go to Azure, Azure cloud. They call it virtual machine to get the same thing done. I have not signed in from quite some time now. I don't know if I would have. Oh, I don't think so. So same thing, friends. If you have an account, I can show you, but yeah, Google. So it's one and the same thing. Okay, nobody's going to reject you on this basis. Understand this. Okay. Able to understand this? Whoever asked this question.
Yeah, I got it. Yeah.
Now, if I go to this is GCP. In GCP, the EC2 I was showing you here, we call it compute engine. I'll get the VM instances. So just the look and feel would change. This is GCP cloud, friends. Here I go to compute engine, I go to VM instances, and I create VM instances. In EC2, in AWS, I go to EC2 and create it. So use case remains the same. So I'll talk about that. These things. Don't worry, just focus on one cloud. Don't worry that you need to learn all the cloud. It doesn't work like that. If you learn one, you can learn others. That's how it works.
Roshan, just one question. I mean, I probably would have missed the first 5 minutes, I guess 5-10 minutes, but may I ask you, like, what is exactly what is your role at the moment, and on what cloud you are working?
Okay, I work on two cloud as part of my current assignment. I work on AWS and GCP. Earlier, I was working on Azure and GCP. Right now, I'm working on AWS and GCP. There are few services deployed on AWS, few services deployed on GCP. Two different customers I'm handling of their entire solution being deployed in the cloud. And I'm taking care of the reliability. All the solutions, I'm responsible for the infrastructure. I'm responsible for their reliability. I work as a consultant there in both the places, and they contact me for any issues if they have. Yeah. For reliability, for cloud solutions. Yeah.
Okay, great. Thanks, Roshan.
So, Roshan, I have one question on the in terms of roles and responsibilities. So let's say being a SRE engineer, what is expected for the production issues? Like let's say there is a production outage, So what is expectation from the SRE engineer? He will be fixing
Okay.
the issues. Like what role is he?
See,
Key role he's playing.
correct. So you understand. So let's say I'll give you one example. Let's say in production, there could be many issues. Response time, above the SLA, errors have increased, status code is not 200, some other status code has increased, errors exceptions have increased. So there could be issues. So now as an SRE engineer, we need to understand at least from the infrastructure perspective. If you see issues on the infrastructure, that's why we need to focus a lot of on the cloud, on the deployment part. From the infrastructure, you need to make sure there is no problem with the infrastructure as such, like contention. You don't have whether you have auto scaling configured or not. You have horizontal HPA cluster auto scale in Kubernetes working or not. From the infrastructure perspective, the routing perspective, ingress, all those things are configured correctly or not. That's one part. Now, if the issue is with the code, let's say, you cannot fix it. Somebody who owns the code can only fix it. But as an SRE engineer, you need to narrow down what is the issue. So you will be the first point of contact. If when any issue comes, like P2 issue, P1, P0 is downtime, P1 is very critical. Let's say and P2 is like a very kind of about to get downtime. Those kind of if P0 downtime comes, let's say if the entire down, the entire company would be in the call. Let's say if Flipkart is down, would they leave anybody in the organization to not be in the call? They would catch anybody, right? Flipkart, Amazon.com is down. They cannot afford to have a downtime. So we talk about a lot of things. What will happen if they have a downtime? We need to plan for it also. Let's say something critical is happening and it's going to impact the customer. Let's say you understood based on some alerts that you have configured. You understood that something not looks correct and you looked into that, you're not clear what's happened. So you should have the plan B. Can you roll back or can you route the traffic to some other cluster? See, that's you need to understand the disaster recovery scenario, DR scenario. Can you route the traffic to another cluster which is healthy? Or can you roll back the changes? Let's say you deployed something in production and it started to happen after 1 hour. So can you roll back the changes? Right? So you need to understand, you need to have a track of what's happening so that you can take decision. No, you cannot fix the issue. Let's say you have mitigated the issue for somehow you routed the traffic, you have somehow find some containment, we are able to contain the issue. Now you need to start some call, uh, right? The why this issue happened, the RCCA, root cause containment analysis. And you can involve the right developers depending on which product the issues was, which microservice. You can call the developers because you would not know as an SRE engineer, you would not know everything about the code, what they have done. And you can make them understand this is the behavior. They would understand more about the application and they can understand if out of memory happening, the problems with the code. There are Kubernetes. We have Kubernetes which creates new containers, new pods. We have auto healing feature replica set. It creates new pods. So it will avoid the downtime. It's fine. You can increase the memory also to as a containment, but memory leakage is gonna come back. So you need to take a dump and understand this. Do the heap dump analysis, let's say out of memory issue, and you can let the developer know, boss, that your code, this has not been written correctly, and because of this method, this class, we are getting out of memory. Look into this, right? So developers, if you SRE engineer is not supposed to fix everything, but you need to be a gatekeeper. You need to drive things. I'm talking about a senior SRE engineer, okay? Principal SRE engineer who is responsible. Yeah. Sounds good to some extent.
Yep. Thank you. Thank you. Yeah.
Yeah. Hi, Roshan. Can I go ahead?
Yes, please.
Okay. Yeah. I am working as a QA professional actually. So I am well versed with Java, Python, and JavaScript, mostly working in Selenium, Java, and all those things.
Right.
I have no knowledge in cloud and performance engineering as of now. But I work in a cloud implementation currently in an insurance domain, and we are using Amazon S3. So, do you think that this course will be helpful for me? And what are the opportunities that I can grab on?
See, I would suggest you, since you're very much closely to do with automation, the DevOps engineering part would be more suited to you because they talk about CI/CD pipeline automation, deployment, code deployment, right?
Yeah.
Not the troubleshooting part. Getting troubleshooting mindset, understanding of architecture, you are not there. You have never done that, right? Understanding of
No.
architecture, flow,
Mm.
so that mindset, it'll take some time for you to develop that. So yes, definitely this course would help you to understand cloud, to understand Docker, Kubernetes, CI/CD pipeline, and other automation tools like Terraform, Ansible. But from your career perspective, I would suggest you first try to be a DevOps engineer. Try to learn about Jenkins and all those automation tools, CI/CD pipeline. How do we do that? Maven, GitHub, and definitely Terraform, Kubernetes, Docker. So this course will definitely help you. But over the long run, if you're looking forward to become an SRE engineer, try to develop the architectural understanding of any solution. Go over the architecture of your own company. Try to understand the architecture, various components. Try to understand the cloud part of it. What are different? Now you talk about S3. S3 is one of the storage, but you have so many other things, right? You have NAT gateway, load balancer, auto scaling group. You have EFS. There are storage service also. We have EFS. We have databases. You have Lambda. You have so many other services. So try to explore, increase your knowledge towards the cloud part. Try to understand the architectural perspective, troubleshooting mindset. That will help you in the long run. Yeah, this course will help you definitely because we talk about all those things.
So this course will include all those things like the cloud architecture and other things. I'm sorry, I have
Architecture,
been
yes,
from the
definitely.
beginning, like, but I cannot connect the dots actually. So that's why I'm asking.
That's why I'm suggesting you to to go for DevOps engineer first. Because we talk about from a SRE perspective, we will talk about cloud. We'll talk about cloud architecture. We'll talk about Jenkins. We talk about Kubernetes, which you anyway need to know as a DevOps engineer. So if anybody looking to become a DevOps engineer or SRE engineer, this course will help you. Now, the troubleshooting mindset, I cannot like teach you as part of this course. You need to have that, right? And it will come over the time. It's not like I spend few hours. I can spend few hours. That will help you to some extent. But if you're really not hands-on, you'll forget things. Right? The Java performance engineering, you will have the recording. But if you're not working on memory, if you're not looking into heap dump, not looking into the Java processes, no point, right? You'll forget heap dump, thread dump. You'll read, but you'll forget. So you need to do this hands-on part. So I would suggest you to try to become a DevOps engineer first. And this course covers what a DevOps engineer requires. So I'm suggesting you to be on the automation zone itself. Automation zone, not the troubleshooting mindset, is what I'm trying to tell you from a career perspective.
Yeah. So having this course, going through this course will help me, or is it like a DevOps
Is it
part?
going to help you? Is it going to help you? Because anyway, we don't cover this as part of the course. I understand that. I assume that you have it. Because performance engineering engineers should have this. And then we try to enhance that from a cloud perspective.
Okay. Thank you.
Hi, Roshan.
Yes.
So actually, I worked there for like 4 years in performance testing, and so I'm enrolled in this course. But like, I just want to know for the heap dump and thread dump analysis. So those are the hands-on will be there here or not?
Correct. We have Java performance engineering.
Like
We have.
as like I have heard like Eclipse MET is used for heap dump threat
Mat,
analysis.
Mat, yes, Mat is very
Yes.
popular tool for heap dump
Yes.
analysis. Yes,
So is
we are
that a like
covering. We are
okay.
covering Mat here.
Okay, then great. Thank you.
So, Roshan, now industry towards AI, right? So I'm just curious, any AI opportunities here for
See,
to building
we need to understand the roles and responsibility of an SRE engineers are huge, many. So we need to leverage AI, knowledge base, Copilot, Chat GPT. We need to leverage that so that we don't start from scratch. So the way we look into explore research Chat GPT or Copilot, the way we do it, let's say somebody asked to automate something and we don't know, then where do we go there? We will go to those AI thing and try to explore what do we have, what solution we have, rather than exploring from scratch. So we should know how to leverage them, and
Okay,
and that's how the trend is going to be. And that's how you should do. That's how people do. Yeah.
right, right. Understand. Thank you.
Let's say somebody asked, they take a backup of database in Python. Oh, you don't know, let's say. Then I'll go to Copilot, explore that, go to ChatGPT, you will get the answer. And then you need to tweak it. So you need to be smart enough to use that. That's what is required. Not to do anything from scratch. Just write Python code to automate this. You will get some answers. You should be comfortable in reading the Python code, understanding it, using it to your advantage. So that skill set should be there. Nobody wants you to be at the, like, you should know everything. No, you should know how to use these AI services for your advantage. Yeah.
Yeah, that makes sense. Yeah, thank you.
Okay, friends. So
Roshan, I think just I have a question. Are you covering any kind of like performance monitoring tools like Dynatrace or Splunk or use Couchbase?
I mentioned this. I mentioned this during this, right? During this part that we are not covering. See, there are 20 tools. I can name it right now, but we are covering only these things.
Okay.
See, understand one thing. So it's, you should know how do we, open source is in demand because companies do not want to pay or invest so much. If you are already using AppDynamics Dynatrace, you will always have the support of Dynatrace and AppDynamics for anything. If you want to create a dashboard, just create a ticket, they will help you. Right? So we are not talking about those things. We're talking about these things. From the log perspective, we have Elastic Stack. From the metrics perspective, we have Prometheus and Grafana, along with CloudWatch and Linux monitoring is what we are covering. Okay, friends, we have extended our session.
Roshan, I have one question. Roshan, I have one question. Can you hear me?
Yeah.
Yeah. So just trying to understand the containers. We spoke about that. I know we'll be talking more about it in coming sessions, but just a very high level. This is what I understand. Whether that is correct or not, maybe can you suggest? I just have put the diagram as well here. What I am trying to say here is within a Kubernetes cluster, I have multiple nodes. Within one single node, I have probably multiple pods. And within one single pod, there are multiple containers that are running. And in each container, there are set of microservices that are running. Is that understanding correct?
Yeah, I will answer you in this way. Okay, I'll open one of the PPTs that you understand what we cover. I'm going to show you a PPT.
Yeah.
So what I'm showing you is the Kubernetes architecture. I'm showing you the VM here. This is the VM. We have container engine running, let's say Docker running. The circle one is the pod and the blue one is the container.
Okay.
Sounds good?
Yeah.
Same
So
thing
within
applies
that,
to them. Yeah.
yeah, exactly what I actually depicted. It is in the same way.
Yeah.
So which is VM here you mentioned?
Come again?
Which is VM in this diagram? In this diagram, whatever you just
This is the VM.
the outer one, right? Okay.
Yeah.
And within container, are we having multiple microservices or is it single
No,
microservice?
one pod can have multiple containers. One container contains only one microservice.
Okay, okay. This is the clarification I require. Okay, thanks. Yeah.
Sure. Okay, friends.
Sorry, I have just a last question. I know you already answered for the QA background people. You are suggesting like we first have to check for the DevOps
Because that's
knowledge.
automation. You are very easily. All I'm suggesting you that troubleshooting mindset, and all performance engineers would agree here that troubleshooting is something you gain over the years. Correct, friends? All of you, all performance engineers, you gain over the years.
That's right, yeah.
You
Would
because
this like I know you already answered about this course as well will be benefited for the QA people as well.
it
If you
will
are
help.
planning to,
Definitely,
yeah.
it will help because we are talking about cloud, we're talking about Kubernetes, we're talking about Jenkins. We cover a lot of things about DevOps. You could become a DevOps engineer using
With
this
this course.
course. Yes.
All right, yeah. Thanks for answering on that question.
Sure.
Thank you.
Thank you so much, everybody. We will meet tomorrow and discuss further, friends. Thank you so much.
Yeah, thank you, Roshan.
Thank you, Roshan. Bye.
Roshan, just last
Yes.
thing. Are you
Thank you,
going to
Roshan.
share the? Are you going to share? Oh, I
This
think you did.
recording? Yes, we'll be sharing.
Yeah, this recording. Yeah,
Yeah.
we'll share. Okay, thank you very much.
Thank you.